Good evening, and welcome to Story of the Cosmos. Tonight, we follow the quiet, fleeting visit of the first confirmed traveler from another star system. A stranger that arrived, was seen, and vanished, all within a matter of weeks. A single faint point of light was crossing the sky, moving in a way nothing born here ever moves. High above Maui, on the cooled black slopes of a dormant volcano called Haleakalā, a telescope kept its patient watch through an October night in 2017. It was built for exactly this kind of vigilance, a NASA-funded survey scanning the darkness night after night, hunting for asteroids that might one day cross paths with Earth. Most nights it found only what belonged there, the familiar rubble of our own solar system, icy wanderers and stony fragments born from the same disk of dust that made the Sun and its planets, all of them tracing orbits that curve, eventually, back toward home. This night was different. Among the usual scatter of faint points was one that did not curve back. It was already receding, already past its closest approach, some 33 million kilometers beyond Earth, by the time anyone noticed it at all. Not arriving, but leaving, caught only in the last quiet moments of a visit no one had known was happening. Nothing marked it as strange to the eye. It was simply a dot of light, dim and colorless, drifting against the stars with a calm, indifferent motion, the way any small rock might drift. But motion, watched closely enough, tells the truth about where a thing has been and where it is going. And this motion did not belong. It was already on its way out. Oumuamua wasn't the only one watching that night, but it was Robert Weirick who saw it first. He was reviewing images from Pan-STARRS 1, a survey telescope on the summit of Haleakalā on Maui, built and funded to hunt for near-Earth asteroids, the kind that might someday matter to us. It was October 19, 2017. What Weirick found instead was already leaving. At the moment of discovery, the object sat some 33 million kilometers away, outbound, fading. There was no protocol yet for what he'd actually found, because nothing like it had a name. For the first 11 days, it looked almost ordinary. Astronomers do this constantly: catch a new point of light, plot its path, wait for the orbit to reveal itself. But by October the 30th, the calculations had settled, and the number that came back had no business being what it was. An eccentricity of 1.20. Anything above 1 means the orbit isn't a loop at all. It's a path that comes in once and never returns, unbound to the Sun's gravity forever. Every comet, every asteroid ever catalogued before this one, belonged to the solar system, tied to the Sun by that quiet gravitational leash. This didn't. So a new designation was created, just for this one arrival. 1I. The I standing for Interstellar, a category that, until that October, had never needed to exist. And then came the naming. Not the clinical shorthand astronomers use for paperwork, but a real name, chosen through a program that pairs Hawaiian language students with the astronomers who make these discoveries. Fitting, since it was Hawaiian skies that had spotted it. They called it Oumuamua, a messenger from afar, arriving first. It is a strange kind of honor, being named by the place that only barely caught you in time. A few years earlier, a fainter survey, a cloudier night, and it would have crossed the entire solar system unseen, in and out, a stranger who left no trace of ever having knocked. But someone was watching. And so, for a few short months, it had a name. By the time anyone found it, its closest brush with the Sun was already more than a month in the past. The story of its passage had to be read backward, out of old images and quiet calculations, like tracing a single set of footprints across a very large, very dark field. It had come down across the plane of the planets from somewhere near the constellation Lyra, falling inward on a path no comet or asteroid born here could ever follow. On September the 9th, it reached its perihelion, its closest point to the Sun, sweeping to within about a quarter of the distance between the Earth and the Sun. That is close enough for real heat, close enough for the Sun's gravity to seize a body and swing it hard. And swing it did. Out among the stars, drifting free of any sun's pull, it had been moving at a gentle 26 kilometers each second, fast by any human measure, but a calm and steady drift by the standards of deep space. Falling through the inner solar system changed that entirely. The Sun's gravity took hold of it, and, at the moment of closest approach, it was moving at just over 87 kilometers every second. Fast enough that no object bound to the Sun, no ordinary asteroid or comet on its usual loop, could ever move that quickly. That speed alone was one of the clearest signs, almost from the very first calculations, that something was different about this one. About 5 weeks later, on October the 14th, it made its closest approach to Earth, a little over 60 times farther away than the Moon. Not a close call, not a near miss in any dramatic sense, but close enough, for a few hours, to feel like a shared moment between two bodies that would never meet again. No planet reached out and bent its path. No giant world's gravity nudged it left or right. Its whole journey through our solar system was shaped by the Sun alone, swinging in, swinging back out on a single unrepeated arc. Then it was gone. Discovered already outbound, already past its closest points to both the Sun and the Earth, it slid back out across the plane of the planets, this time heading roughly toward Pegasus, carrying its interstellar speed with it once more as the Sun's pull faded behind it. The whole encounter, fall, swing, departure, took only a matter of weeks. A brief crossing of a neighborhood it would never revisit. A single pass. Then gone for good. For a few hours at a time, Oumuamua all but disappeared, then flared back, 10 times brighter than before, and just as quickly dim again. That swing alone told astronomers something almost nothing in our own solar system does. A change in brightness that steep, repeating every few hours, meant an object with a long face and a narrow one, tumbling end over end, catching sunlight broadside one moment and edge-on the next. The team that first modelled it, working from that flicker of light, sketched something startling. A body perhaps 230 meters long, but only about 35 meters across, 6 or 7 times longer than it was wide, and some early readings hinted at an even more extreme, almost 10-to-1 shape. Nothing shaped quite like that had ever been seen drifting through our neighborhood before. But the shape was never something anyone actually saw. Even to the largest telescopes on Earth, Oumuamua was only ever a point of light, a single pixel, brightening and fading. Every long silhouette, every cigar-shaped rendering, was a reconstruction, an inference built from that flicker rather than a photograph. And a few years later, other researchers went back over the same data and found the extreme 10-to-1 shape wasn't the only story it could tell. A flatter form, something closer to a pancake than a cigar, fit the light curve just as well. To this day, no one can say with certainty which one it was. Only that it was strange, and long or wide, and unlike the tumbling rubble of any asteroid we've catalogued. That tumble itself was its own kind of clue. Oumuamua wasn't spinning cleanly on one axis, the way most small bodies do. It was tumbling chaotically, end over end, off balance, in a way astronomers call non-principal axis rotation. Something, at some point in its long life, had knocked it off its rhythm. A collision, perhaps, or the wrench of being torn loose from whatever star it once orbited. And its surface, whatever its shape, wore a color that felt oddly familiar. A deep, weathered red, the same reddish tint seen on the ancient Trojan asteroids trailing Jupiter, and on the frozen bodies scattered through the Kuiper belt at the solar system's edge. That color is what billions of years of cosmic rays do to organic ices and compounds. A slow chemical sunburn, patient beyond imagining. Yet for all that comet-like weathering, Oumuamua showed none of a comet's usual signs. No glowing coma, no dust catching sunlight in a tail. Whatever gas may have quietly stirred beneath that red crust, it never once flared into the visible plume that comets are known for. It simply passed by, dark, silent, tumbling, looking at once like something we already understood, and like nothing we had ever measured before. A shape no one could quite pin down, a color that spoke of ancient exposure, a silence where a tale should have been. A tiny, patient nudge, one that took months of careful tracking even to notice at all. As Oumuamua fell back out of the inner solar system, retreating toward the dark it had come from, astronomers watching its path noticed something wrong. It was moving very slightly faster than gravity alone could explain. Not much. A whisper of extra speed, the kind of thing that shows up only after weeks of patient measurement, plotted and replotted until the discrepancy refuses to go away. In any ordinary comet, this would mean nothing at all. Comets pick up exactly this kind of gentle push all the time, as sunlight warms their ice and jets of gas hiss quietly out from underneath, breath by breath, nudging the body forward like a tiny, uneven engine. But Oumuamua had shown no such breath. No coma. No tail. No visible gas, no dust, nothing streaming off its surface in any image any telescope ever captured. And yet, here was the signature of exactly that kind of venting, written into its speed, with no visible source at all. For more than 5 years, this stayed one of astronomy's quietest open questions. Not loud, not urgent, just patient, unresolved, sitting at the edge of 100 conversations about what Oumuamua really was. A few explanations were offered and set aside. One, briefly, imagined the whole object as a fragment of pure, frozen hydrogen, until researchers realized that a body made of something so fragile could never have survived the long, starlit crossing between the stars. It would have boiled away to nothing long before it ever reached our sun. The most convincing answer yet had been sitting, unnoticed, in laboratory data from decades earlier. Ice experiments run in the 1970s through the 90s, long before anyone had a reason to connect them to a visitor from another star. In 2023, a study proposed something quieter than an engine and stranger than a comet's ordinary breath. Water ice, when it drifts for millions of years through interstellar space, is struck endlessly by cosmic rays, high-energy particles that slowly, invisibly, rearrange its molecules. Some of that irradiated ice ends up trapped with pockets of molecular hydrogen, sealed inside like air inside a held breath. And when that ancient ice finally warms, even briefly, even gently, in the light of a passing star, the trapped hydrogen doesn't need a crack or a plume to escape. It simply seeps free, molecule by molecule, too faint and too clear to ever show up as a tail, but more than enough, spread across a tumbling, elongated body to shift its course by exactly the tiny amount observers had measured. No alien engineering, no exotic material never before seen in nature. just old ice, doing what old ice does when it finally feels warmth again after however long it had been drifting in the cold. A visitor's frozen memory of starlight, quietly leaking out as it left. It was the kind of answer astronomy rarely gets to give. Not a discovery so much as a recognition. The pieces of a decades-old laboratory result and a brand new interstellar mystery finally fitting together. The push had never been a message. It had never needed to be. It was only ice remembering the cold it came from and letting a little of it go. A quiet chemistry could account for the whole strange push. The debate has not fully ended. No explanation can ever be tested against a visitor that is already gone. But nothing in the story has ever required anything stranger than physics. And Oumuamua sailed on, unchanged, unbothered, carrying its answer with it into the dark. A sail thin enough to ride on sunlight alone might be no thicker than a few sheets of paper, stacked one on another, and for a little while it seemed possible that something like it was already out there, tumbling past us. In November of 2018, the Harvard astronomer Avi Loeb and his colleague Shmuel Bialy offered a different kind of answer to Oumuamua's quiet push through space. Not trapped gas. Not ancient ice venting under sunlight. Something built. A membrane no more than a fraction of a millimeter thick, they suggested, could be pushed by starlight the way a curtain lifts in a draft, light enough, wide enough, to explain the faint acceleration without needing any comet's breath at all. It was a careful piece of physics, offered as one possibility among several. But once it reached the wider world, it became something else entirely. A whisper that humanity's first interstellar visitor might not be a rock at all, but a sail. A message, however old and silent, from somewhere else. The idea traveled fast and far, the way such ideas do. But the scientists who studied Oumuamua most closely did not follow it. Matthew Knight, at the University of Maryland, spoke for much of that community when he and his colleagues concluded that everything observed, the tumbling, the color, the shape, the strange nudge outward, was consistent with a natural origin. Not one measurement ever required an artificial explanation over a natural one. The sail remained a thought experiment, elegant, tempting, and ultimately set aside by the evidence itself. And long before the idea had even found its audience, someone had already gone looking for a more direct kind of proof. In December of 2017, only weeks after Oumuamua's discovery, the Breakthrough Listen project turned the 100-meter Greenbank telescope in West Virginia toward the object, listening across 4 wide radio bands, from 1 gigahertz up to 12. For hours, the largest ears humanity has ever pointed at the sky gathered everything arriving from that faint, retreating point of light. 90 terabytes of data in the end. 4 wide bands of radio light, combed channel by channel. And underneath all of it, nothing. No pulse, no pattern, no signal shaped by an intention rather than a star. Just the ordinary hiss of space, the same hiss that fills every silent hour of listening humanity has ever done. It was not a disappointment exactly. It was something closer to honesty. A quiet confirmation that some questions deserve to be asked plainly, tested carefully, and answered without flinching, even when the answer is silence. So, Oumuamua kept its secrets in the way that felt, in the end, most true to what it was. Not a herald, not a machine, but a wanderer. Reddish, tumbling, unlit by anything but reflected sunlight, moving through 100 terabytes of human attention, and leaving behind only the faintest trace of itself. The sail hypothesis remains a beautiful question, unresolved because it was never truly needed. The silence remains complete. No signal was ever found. Silence sounds like nothing at all. But for 5 years, it was the loudest unanswered question in the story. And even now, the deeper question behind it, where did this thing come from, has no answer at all, and never will. Young planetary systems are messy places. While planets are forming, giant worlds swing through their newborn systems like slow wrecking balls, flinging icy debris outward with every close pass. Models suggest the process is not rare. Each star system may eject something like a full Earth's worth of leftover ice and rock over the course of its youth. Countless small, cold bodies scattered out of their birth systems entirely, sent drifting into the space between stars. Oumuamua was, in all likelihood, one piece of that scattering. Somewhere, once, it orbited a star. It likely formed the way such bodies usually form, in the cold outer reaches of a young system, gathering into ice and rock, waiting. And then, at some point in that system's early chaos, something, perhaps a giant planet's gravity, caught it, bent its path, and let it go. Not into a wider orbit, but out. Free of its star's pull entirely. Free of everything. After that, there is only drifting. No sunlight to warm it in any meaningful way. No star's grip close enough to bend its course. Only the galaxy's slow, vast pull, carrying it on a long, quiet drift through the dark between stars. One study of its reddened, irradiated surface suggested it may have spent as little as around 30 million years adrift after its ejection. Young, in cosmic terms. Other models allow for a journey many times longer, stretching into the hundreds of millions of years. Nothing about Oumuamua itself can settle the question. And that uncertainty is not a small gap in the story. It is the reason its birthplace can never be recovered. To trace Oumuamua backward to its home star, astronomers would need to know exactly how fast it drifted, in exactly what direction, for exactly how long. But a journey of tens of millions of years, let alone hundreds of millions, is not a straight line anyone can simply run in reverse. Stars themselves drift. The whole galaxy shifts and turns around them over spans of time that long. The star that once held Oumuamua in orbit is no longer where it used to be, and neither is anything else. So the question of where Oumuamua came from is not a mystery waiting for better instruments or a cleverer calculation. It is a door that closed the moment it was ejected, sealed further with every star it passed on its way to us. Whatever world once assembled itself around it, whatever planet flung it loose, whatever star warmed it as a young thing at the edge of formation, that star has no name we will ever know. It arrived from everywhere, and nowhere in particular. This time, the visitor announced itself the old-fashioned way, with a glowing tail that gave it away. 2 years after Oumuamua slipped past unnoticed by everyone but a single telescope, a second visitor arrived, and this time, it looked exactly like what a comet should look like. Discovered in 2019, Comet Borisov trailed an ordinary glowing coma and a gas tail streaming behind it, the familiar signature of ice turning to vapor in sunlight. No ambiguity, no mystery shape tumbling end over end. And yet, inside that ordinary-looking tail was something quietly extraordinary. When astronomers studied its chemistry, they found far more carbon monoxide relative to water than any comet native to our own solar system carries. A comet built from a different recipe than anything the sun ever cooked. Proof, gentle and understated, that other stars assemble their icy debris by different rules than ours. Then, in the summer of 2025, a third messenger arrived. Discovered on July 1st by a survey watching the skies over Chile, this one was no fragile sliver of rock. Its icy nucleus, perhaps a few kilometers across, many times the size of Oumuamua, 3I Atlas came through active and unmistakably alive with venting gas, large where Oumuamua was small, energetic where Oumuamua was silent. 3 visitors now, 3 strangers from 3 unknown stars. And no 2 of them alike. One a bare, tumbling sliver with no tail at all. One an ordinary comet built from unfamiliar ice. And one an active giant, larger than a mountain range, sailing through on a trajectory that will also never return. If interstellar space is scattering pieces of other worlds through our solar system, it is doing so without any pattern we can yet name, each traveler arriving as its own kind of surprise. Oumuamua, it turns out, was never the template. It was only the first. And so it rests. Somewhere out beyond the Earth, at a quiet gravitational balance point on the far side from the Sun, a spacecraft will one day sit and wait for something that does not exist yet. That is the plan behind Comet Interceptor, adopted by the European Space Agency in 2022 for launch toward the end of this decade. It will travel out to the second Lagrange point, park there, and simply wait, sometimes for years, fueled and ready, with no destination chosen in advance. When the next long-period comet or interstellar traveler is spotted, it will leave on short notice to meet it. No mission before it was ever built this way, designed from the start to chase a target that did not yet exist when it launched. On the ground, a different kind of readiness has come online. The Vera Rubin Observatory, with its wide-field survey camera scanning the whole visible sky again and again, is expected to find these rare, hyperbolic visitors far more often than ever before. The ones passing through on paths that never bend back toward home. Oumuamua slipped past almost by chance, caught for a few weeks by a telescope built to watch for something else entirely, gone from view within months. It was strange among strangers, its shape unresolved, its acceleration unexplained for years, its birth star forever untraceable. And by the time astronomers understood how rare a thing they had glimpsed, it was already too faint to hold on to. It will not stay the last of its kind, or even the strangest. Somewhere out past Pegasus now, it drifts on, cooling in a dark it has crossed before, and will cross again for the rest of time. The next messenger is already on its way. This has been a story of the cosmos. Out there, the stories go on, slowly, quietly, as they always have. Let this one drift on without you, until the next journey.